This is pre-calc section 3.7, topics in the theory of polynomial functions. The first one says find a quadratic function with zeros 4 and -3. This is where we work backwards. X equals 4, x equals -3. Those are our solutions. Those are our answers. Work your way backwards. Where did that come from? That would have come from the factor x minus 4. This would have been the factor x plus 3. And of course, we would have used the zero product property to get those solutions, and that's why we put this equal to 0. And then just FOIL this out. We'll give you x squared minus x minus 12 equals 0 as far as an equation. The only thing is, this asks you for a quadratic function, so instead of having a 0 here, this should be equal to f of x or p of x, whatever letter that they are using. Now, there's a neat little shortcut for finding this. Rather than having to take these zeros and put them in factor form and then FOIL them out, take a look at the relationship here. Notice the n. That's the easiest thing to see. Where this -12 came from was FOILing out these numbers. 4 times -3 gives me -12. So if we're calling these two the 4 and the -3, if we call this root 1 and root 2, then to get the last term, all you have to do is multiply root 1 times root 2. To get the middle term, we just have to watch what we're doing here. This root, or these roots, or zeros, became the factors x minus 4, x plus 3, which means there was a sign change here. So what we do with these roots is we add the roots together to get the middle, but we then change the sign. Now the reason we add is because of the FOILing. If you FOIL this out and look at your work, this is -4x, this is plus 3x, when you do this part of the FOILing, and you add those together to get the -x. But the reason it's -x is because we had already changed the sign going from 0 to factor. So if you want to use a shortcut, you start by x squared minus something x. The reason it's minus is because I need to remember to change the sign. So if you put the negative there as you do the problem, you'll get the sign change automatically. Add these together. 4 plus -3 is 1. Put the 1 here. And we did change the sign because in this little template I laid down, I changed the sign already with the minus. Then multiply these together. 4 times -3 is -12. So minus 12 equals either f of x or p of x. So just pretend you had zeros of 7 and 4, and we don't want to go through all of this work over here. Start with x squared minus something x. Now start with your arithmetic. Add these together. 7 plus 4 is 11. Multiply these two things together is 28. Equals f of x or p of x. So that's the process I'm going to use when I'm finding these polynomial functions. So 5, 9, I'm going to start with x squared minus, add these together. 5 plus 9 is 14x. Multiply them together, plus 45 gives me f of x. And see, this little shortcut works whether you're dealing with whole numbers or imaginaries or radicals. Start with x squared minus. Add these together, which may look complicated, but it really isn't. If you add 2 plus 3i to 2 minus 3i, what happens to the 3i's? They cancel. 2 plus 2 is 4x. And when you multiply these together, this is a simple FOIL, but you really don't have to do the whole FOIL because this is set up with these being conjugates so that when you multiply these together, it will be opposite signs in the middle. 2 times 2 is 4. I don't really need to do the outside and the inside because they're going to cancel out. Minus 9i squared. Remember your complex numbers. I squared will cancel out and change the sign to a positive 13. Equals f of x. Works with radicals also. X squared minus, if we add these together, the radicals are going to cancel out. 3 plus 3 is 6x. Multiply that together, and it's the same as what we just did with the other. I don't have to do the full FOIL. I can do 3 times 3 is 9, minus radical 2 times radical 2 is 2, which gives me 7 equals f of x. This is another fact that we talked about in college algebra. It's called the conjugate zeros theorem. If p of x is a polynomial function having only real coefficients, which is basically all we deal with, and if a plus bi is a 0, then the conjugate a minus bi is also a 0. Meaning if you know or you're given that 2 plus 3i is a 0, then automatically so is its conjugate pair, 2 minus 3i. So let's do a problem here where we find a cubic polynomial in standard form with real coefficients having these zeros. Well, a cubic polynomial says I should have 3 zeros, and I really do. I was given 3, I was given 2i, and automatically its conjugate, which is negative 2i, is a 0. I'm going to use a shortcut on these two. It makes sense to put the two imaginaries together because the way things happen with canceling out. So start with x squared minus, well, this is kind of weird. This is really 0 plus 2i and 0 minus 2i. If you add those together, all of this cancels out and we really don't have an x term. Multiply these together, 2i times negative 2i is negative 4i squared. Cancel out the I squared, change that coefficient, and that gives me plus 4. So to write this more neatly, the quadratic that has those two zeros will be x squared plus 4. And you could verify that by doing it the long way, which is x minus 2i times x plus 2i. And that will show you that the middle stuff canceled out and we end up with the 4i squared at the end. Now the other thing we have to do is put this together with this 0. I have to write it as the factor x minus 3. There's no way around that. I've done the shortcut with these two to get my quadratic, but then I have to come back and multiply this up using FOIL. So x times x squared is x cubed plus 4x minus 3x squared minus 12. But I want to rewrite this in descending order. Plus 4x minus 12 equals the polynomial. Now, I did this exactly in FOIL order. I didn't have to. Knowing what's going to happen here, I could do x times x squared. I could then do 3 times x squared to give me the 3x squared, and then do the other multiplication. But if you feel safer doing the original FOIL and reordering, that would be fine. Here's another one. Here's our zeros. And we're going to come back and deal with that part. We did one of these in college algebra also. So find the cubic function with those zeros. Now I can put together any two that I want. I choose to put these two together. So using my shortcut, x squared minus, add those together, negative 3 plus 1 is negative 2. But minus a negative is going to make this a positive 2x. Multiply those together, gives me negative 3. So here's my quadratic, x squared plus 2x minus 3. But now I have to deal with this. If you have a 0 of 0, that means the factor would be x minus 0, which is really just a plain old x. So distribute the x through there. It's x cubed plus 2x squared minus 3x. Would be my function if they hadn't given me this extra fact here that f of 2 has to equal negative 1. If I put 2 in here, 2 cubed is 8. Put 2 in here is also 8. Minus 6, of course you could do that in calculator if you wanted to. Add this up is 10. Well, my function gives me f of 2 equals 10. Their f of 2 is negative 1, which is what it's supposed to be. So how I finish from here is this little fraction. I do a little fraction of should over got. And what I mean by that is it should be negative 1. That's what they told me it should be. The got is what I got. I got it to be 10. I look at that little ratio, and that becomes my coefficient. I need to multiply negative 1/10 times that whole function, which gives me negative 1/10 x cubed. Negative 1/10 times 2 reduces to negative 1/5 x squared. Negative 1/10 times negative 3 is positive 3/10 x, and this will equal f of x. Find a cubic function with those zeros. Notice that your radicals are coming in conjugate pairs also, so I can use a shortcut on those, x squared minus, add those together. What happens to the radical 5s is they cancel, so this is just 4 plus 4 is 8x. We do need to do a little bit of work with multiplying, but it's not horrible because I don't really even have to do the full FOIL. because 4 times 4 is 16. I know the outside and the inside product will cancel, so why bother? Minus radical 5 times radical 5 is 5, which gives me 11. So that is the quadratic for those two zeros. I need to go back and write the 0, 3 as the factor x minus 3, and then multiply this out. So distribute the x times all of this is x cubed minus 8x squared plus 11x. Then come back and do negative 3 times all that, and I line it up this way. Negative 3x squared, negative 3 times negative 8x is positive 24x. Negative 3 times 11 is negative 33. You could string it all out horizontally, but I just make it just is easier for me if I line it up vertically, because then my like terms are lined up. Minus 33 equals p of x. This is just like the last problems, but instead of coming out in words and telling you what the zeros are, you have to pick them off the graph, and it's very easy. Your zeros are the same as your x-intercepts. So your zeros are negative 6, 4, and 7. Furthermore, f of 0 better equal 84 when I'm finished. So we'll deal with that at the end. Here's our zeros. I'll just put the first two together. Using my shortcut will be x squared minus negative 6 plus 4 is negative 2. So it's minus a negative 2x. Multiply those together is negative 24. So really, this is x squared plus 2x minus 24. I need to come back and multiply that by the factor x minus 7. So multiply this up, x cubed plus 2x squared minus 24x. Come back and multiply everything by negative 7 and line it up. Negative 7x squared minus 14x plus 168 gives me x cubed minus 5x squared minus 38x plus 168. Let's do f of 0 for this. F of 0 for this, if you put 0 in for all of those x's, they all go away and we just get 168. So here's my ratio of should over got. I should have an 84 because that's what they told me. I got a 168. That reduces to 1/2. That says I need to take my polynomial right here and distribute 1/2 all the way through the polynomial. So my answer will be p of x equals 1/2 x cubed minus 5/2 x squared minus 19x plus 84. And there's our polynomial.